when we're talking about integration, it's important to understand that there's two types of integrations. There's the physical integration, which is taking object A and object B and adding them together. There is architectural integration. My belief is that architectural integration is actually likely to be working in the opposite direction. And the reason for that is because we're starting to develop this understanding that there's a new class of processors that would be really beneficial to mankind. That the task parallel sequential processing instruction set architecture that makes up the CPU is a work of art, and it's a work of brilliance, and it's wonderful, but it's not enough. And it's not enough to solve a lot of the problems that we have today, which is data parallel in nature. And if you have a data parallel type of problem, there's no reason not to have a data parallel type of processor, because we have an infinite number of transistors anyway. Mm-hmm. Why?
And they're free.
And they're free. So why do all of the work in the world with a screwdriver when you can have a screwdriver, a plier, and a hammer? Right? There's nobody holding you back. Mm-hmm. It's not transistors. God knows customers aren't holding you back. And so there's no reason not to have two architectural processors. It turns out that it's much easier to program. That the programming environment, putting the right jobs on the right tools, is much easier than trying to fit everything into a MIMD machine. And so I think the industry is now developing that psychology and that perspective. And it's
which psychology?
That heterogeneous computing is the best way to go. And so I think heterogeneous computing from an architectural perspective has now become, if you will, a foregone conclusion. Mm-hmm. 2 years ago, before CUDA showed up, everybody questioned that. Everybody's, Jensen, this is just for GPUs. But heterogeneous computing and CUDA is now being taught in 40 universities around the world, all the best universities in the world. Almost every supercomputing center is going to be using it. It's a foregone conclusion now. Okay. So now the question then becomes the physical integration. Well, physical integration has been happening for some time, and the question kind of goes like this: what's the difference to me whether Intel integrates the GPU or the graphics chip into their chipset or their CPU when the two are bundled together? The answer is no difference. They've been integrating and bundling forever. Our dynamics, our requirement as a company, is to make sure that we provide either technologies or solutions or capabilities that is not available on the basic plan. If you will, our business is like Adobe's. Microsoft has photo editors and movie makers bundled right into the operating system. It's right there on the start button. It's free. It comes with every single computer. You've got to be obtuse not to notice it.
And how big is that?
And Adobe yet still survives. And so we are positioned very much like Adobe as a company. Whereas Adobe supports the Mac, they support Windows, they support Linux, they support whatever operating system.